Welcome to Geometry, Topic 3, Section 5. We're going to be talking about symmetry and how that relates with reflections and rotations. I would like you to do this explore and reason piece here at the beginning on your own. Please answer parts A, B, and C. This is a great place to pause your video, and if you noticed, this is on paper again, which means you need a compass and a protractor, and if you have it, some sort of piece of tracing paper. We talked about this in another video. Wax paper. This is parchment paper. It works really well. Even a blank piece of white paper will work, and will just be really helpful for you to be able to see different things that we're doing. Let's go ahead and jump into example 1. What transformations can be used to map the figure onto itself? And why can some figures be mapped onto themselves and why can't some? We're going to talk about that today. The first thing we want to do today is we're going to trace this picture so that we can look at the things that are happening with it and explain why it can and cannot do different things. So this paper doesn't write quite as well as some other paper. I'm going to actually try pencil for this. Actually, pencil's working quite a bit better than my pens. So I'm going to just trace the shape. And we're going to talk about how we could rotate it and have it come back onto itself. So let's start by, of course, we need a point of rotation, right? So let's see what would happen if we rotate from this upper right-hand corner. And if I rotate it around 360 degrees, it's going to map back onto itself. So we know that rotations of 360 degrees are going to work. And that's really, it would be the same no matter the point of rotation or the center of rotation. I can pick that here. And if I go 360 degrees, that's always going to work, no matter where. I could put a point in the middle of this, and I could rotate it 360 degrees, and it would still come back. But notice what happened on this point in the middle. And this is a little bit harder to see with my hand in the way. I'll try and do it like this. I don't actually have to go 360 degrees to map this back onto itself if I have it lined up correctly. I only had to rotate this 180 degrees. So all rotations of 360 degrees work. And then for this one, we have a rotation, which is small r, of 180 degrees, about the center, right? And we would need to identify that there was a point P here, that we have that rotation. Okay, rotating 180 degrees. It will not work if we rotate it around just any point, because if I rotate this 180 degrees, it will not map it onto itself. It would map it to a different location. It's important to note that while we have a rotation of a positive 180 degrees, which would be counterclockwise, we would also be able to do a rotation of a negative 180 degrees, which would around point P, which would take us in a clockwise. So just as a reminder, this one would be counterclockwise. And this one is clockwise. All right, we're going to go ahead and look now at reflection and what happens with reflection. There exists a line through the middle of this. We're going to call this vertical line right here. We will call that M. And please note that we can reflect 180 degrees across M. So we'll put that dashed line there so we can line it back up. And we reflect across there. And we see that we've mapped the shape directly back onto itself. So we have a capital R for reflection, 180 degrees about line M. There also exists a horizontal line through the middle of this shape. And if I look at this, I can mark line P and I can mark this. We'll call this line N. And we will see that we can actually reflect 180 degrees over there. So we have a reflection of cross line N. Technically on this one, because we're reflecting, we didn't actually have to say 180 degrees. Let's call that a reflection across M. So these lines that are going through here that allow us to reflect the shape onto itself are called lines of symmetry. We're going to go ahead and jump to this definition. I'm going to go ahead and just do this on paper rather than digitally this time. Hopefully you guys can read it. It says that a reflectional symmetry is a symmetry for which a reflection maps the figure onto itself. And rotational symmetry is, this should say an image mapped onto the pre-image after a rotation of less than 360 degrees. Because 360 degrees, we discovered, always works for every shape. If I turn something 360 degrees around its center, it's going to be mapped back onto itself. So the only ones that we really say have rotational symmetry are those that are less than 360 degrees that get there. And just as a quick reminder for you, remember that lowercase r represents rotation and uppercase R is our reflection. I'm going to make this an uppercase R so that it's uppercase in both places. So this is case sensitive. You guys know what case sensitive is. You use it for passwords. You have to use lowercase for rotation. You have to use uppercase for reflection. Otherwise, we're going to get confused. Go ahead, pause your video and try it and see if you can locate ways to reflect or rotate these. 360 doesn't count, but to be able to create a mapping of itself. So you're looking for reflectional symmetry or rotational symmetry. If you could not see this just on your own, it might be really helpful to use your tracing paper for this. And do this. And then I'll put a point in the middle, and I'm going to go ahead and put an arrow up so that I can make sure that I know how far that I went. A rotation of 90 degrees didn't do it, but a rotation of 180 degrees worked for me. So I have a rotation 180 degrees. And then we would say, we'll put P there, about point P. And you should have been able to find a line of symmetry here and a line of symmetry here. We could call this X. We'll call this one line Y, or sorry, can't call them both X, can't call that one X and Y. We'll call this one X, we'll call this one Y. And so then to be able to see that this reflected this way or it reflected this way, both of them will map that shape onto itself. So you should have had a capital R reflection across X and a reflection across Y. If you use different letters for those lines of symmetry, that is totally fine. On the second one, we are not just looking at the circle here, we're looking at the whole picture. And so if I look at this and the rotation around it, there is actually not going to be anything other than the 360 that works. And remember, 360 doesn't count. We don't get to count that as rotational symmetry because that works for everything. Okay, so we stop right here. Rotation does not exist for this. So now we're looking to see if there are lines of symmetry that will work. So if I draw a line across the middle this way, and I reflect it this way, that is not going to work. Let's check for a line of symmetry this way. And I'm going to reflect it across that line and see that that does work. So we have, let's call this line S and line T, and S did not work, but a reflection across line T worked.